Welcome to this explainer on API 661. It's literally the ultimate playbook for industrial air-cooled heat exchangers.
So let's dive right in. How exactly do you cool down a massive petrochemical refinery safely and efficiently?
We're breaking the standard into 4 distinct need-to-know pillars for your next engineering project. First up, the lingo. A bay is basically the fundamental building block of these massive cooling structures. Another crucial term, winterization. It literally prevents catastrophic fluid freezing when extremely cold air hits the system. Check out how these core components, the tube bundles, fans, and plenums, physically stack up together. They mostly come in 2 setups: forced draft blowing air through the tubes, or induced draft pulling it in. Now for the rules of engagement. Think of API 661 as a strict matchmaker between purchaser and vendor. The purchaser sets the ground rules, demanding specific pressure design codes and harsh environmental operating parameters. In return, the vendor brings the exact technical blueprints, performance curves, and equipment guarantees to the table. Right, so to actually win the bid, vendors absolutely must follow this strict sequence for their proposals.
And once it's built, vendors are strictly required to hold onto these highly specific records for 10 years.
Okay, moving on to hardware design. Here, the standard outlines some incredibly specific, non-negotiable engineering rules. To stop tubes from sagging and ruining delicate fins, supports can't be more than 1.83 meters apart. Gravity is huge here. Single-pass condenser tubes must securely slope downwards at least 10 millimeters per meter. Unless specified otherwise, carbon steel parts automatically get at least 3 millimeter allowance just for corrosion. But heads up, you get absolutely 0 extra corrosion allowance for the actual tubes or gaskets themselves. To ensure efficient cooling and prevent air bypassing, any structural gap wider than 10 millimeters must be sealed. You can really see how these strict rules physically shape the fan geometries, driving all that massive airflow. Volatile operations like high-pressure hydrogen or super corrosive sour gas demand a lot of special attention and documentation. Ultimately, this API standard is the absolute baseline for engineering safety and performance in petroleum heat exchange. So, if API 661 is just the bare minimum, what cutting-edge cooling innovations are you ready to build?